Okay, this is for review and for people who miss class time. One thing I would like to suggest, especially if you missed this presentation in class, is to come in and use the model kits to actually make the shapes so that you can see them. Because this presentation is 2D and many of these shapes are 3D. So just keep in mind that models, even the little model kits that we have in class, they do not show everything. Some of the major oversimplifications we have is the fact that everything is the same shape. Carbon is a much smaller atom than chlorine, which is giant compared to hydrogen. Okay, there's also, you don't see the lone pairs on our shapes and things like that, so that you have to remember those are still there. So just keep that in mind. So Vsepr stands for valence shell electron pair repulsion. It's a complicated way of saying that the electrons, the valence electrons in the bonds and in the lone pairs, want to spread out as much as possible. They repel each other. Okay, so it's one reason why if you have, say, a water molecule, okay, you don't draw it like this with the hydrogens right next to each other. You draw water, and we'll get into even more why it's drawn at that bent angle, because there's lone pairs and electrons in bonds that need to spread out from each other. Okay? So, to predict a Vsepr structure, start by drawing your Lewis structure. You need to know what bonds you have, what lone pairs you have, because that information helps you find your steric number. Okay, so for example, this compound, if you are worrying about central atom being our carbon, that carbon has a steric number of 3. And that is because there are 1, 2, 3 atoms attached to it. Okay? Whereas, say, methane, which is CH4, has a steric number of 4, because there's 4 atoms attached to it. Then, as far as how you use lone pairs, in the same molecule, the carbon, chlorine, and oxygen molecule, if we put our lone pairs on oxygen, oxygen also has a steric number of 3. 1 for the atom, and then 1 for each lone pair. Okay, whereas chlorine, with its lone pairs drawn on, would have a steric number of 4. 1 for the carbon bonded to it, and then 3 for the 3 lone pairs. Alright? This is going to come in the next few slides. The rules behind how things are shaped. Now, if you have a very complicated molecule, where you have more than just one central atom, then you may have to repeat this for the attached atoms. So, steric number 1. The only thing that ever has steric number 1 is a hydrogen. Okay, so it is the only thing that can bond to one atom and have no lone pairs. So, and hydrogen bonded to anything, another hydrogen, a chlorine, an oxygen, whatever, forms a linear shape, or it forms a line. So, steric number 2 involves 2 atoms. Okay. So, what you have here is you can have an atom bonded to 2 things. An example of that would be carbon dioxide, which is carbon double bonded to oxygens, and focusing on carbon being your central atom, because the steric number would be different on the oxygens. That forms a linear shape. Or, if you were to think about this molecule, C triple bond N, which has lone pair there, HCN. If you are going from the point of view of the nitrogen, nitrogen has 1 atom bonded and a lone pair, so a steric number of 2, and this bond is linear. It forms a line. Again, these are ones where if you can use the model kits to actually set them up, you can see that the atoms form a line. Okay? So, steric number 3, we finally get into some other shapes. So, steric number 3, there's going to be 3 atoms bonded or some combination of atoms and lone pairs that make up 3. So one molecule that is a good example of all of this, and again, especially here, it gets easier to see that this is a flat planar molecule when you actually have the models compared to something else we're going to see later. But this compound forms a flat planar molecule around the carbon. Alright, and that's this one. And then if you focus on the oxygen, it forms a linear molecule with the carbon because the lone pairs go to the outside. Right? Again, it's easier to see these things when you actually have the compound. Something else, just in case it's throwing you off on here, the yellow parts, those are your lone pairs. So they're drawn on here so you can see that there are 3 parts or 3 things around that central pink atom, but lone pairs don't form bonds, so those don't actually show up in the shape. Okay? And then H and O, it's going to be double bonded to oxygen and single bonded to hydrogen with a lone pair up here, forms a bent molecule. Okay, so if you, with the model kits, took one of the black carbons and used it as a nitrogen instead, double bonded it to an oxygen and put on a single hydrogen, it would form a kind of V or bent shape. Alright, steric number 4, this is as far as you need to memorize and know things and be able to identify shapes. But steric number 4 is going to involve 4 sites. So either 4 atoms bonded or a combination of atoms bonded and lone pairs to make a total of 4. So you get the tetrahedral shape if you make carbon trihydride or carbon tetrachloride or anything where you have carbon attached to 4 different atoms. The carbon forms a tetrahedral shape that has definitely a 3D-ness to it. Okay. Ammonia, what you do is you take this bond out and then put a lone pair up here. So you're left with that bottom triangle that's actually being pushed down or pushed away from the lone pair. So it's not flat anymore. It forms a pyramid. Okay. If you have 2 lone pairs like water, water has a bent shape because the lone pairs up here are pushing the hydrogen-oxygen bonds away. Okay, and that's to spread things out as much as possible in 3D space. And then linear, you'll run into this when you have a halogen bonded to something, because the halogen will always have those 3 lone pairs and then a single bond to hydrogen or a single bond to something else. But the lone pairs, since you don't actually see those, just work to make this a linear shape. Okay? So to kind of sum up the things that you need to be able to do, or what you're responsible for, is really, there's not that many shapes that we've gone over here. Seems like there's been a lot of information, but for the most part, you need to know if you need to be able to identify something as linear. You need to be able to identify something as trigonal planar. You need to be able to identify things that are bent or angular, tetrahedral, or trigonal pyramid. Those are the only 5 shapes you are responsible for being able to name and identify. Okay, so what you have to come up with is ways to remember. So things like trigonal always have 3 atoms attached to them. Alright, trigonal planar is 3 atoms and no lone pair. Trigonal pyramid is 3 atoms with a lone pair, because the lone pair pushes the atoms down and it forms that pyramid. Tetrahedral, tetra means 4. So there's always going to be 4 atoms bonded to your central atom if it makes a tetrahedral shape. Okay, we'll practice with this stuff, and you should be able to pick up on some hints as far as how to remember when these shapes are. But you need to be able to identify these shapes, and of course, identify steric number. But steric number is pretty easy. Just so you're aware, there are higher steric numbers. There's steric 5, 6, steric number 6, and steric number 7. Other than if I gave you this compound and you should be able to tell me that the steric number is 7, that's the most you'll have to do with these. These are things that are exceptions to the octet rule. Because here, the pink atom has 1, 2, 3, 4, 5, 6, 7 things attached to it, which means there's 14 electrons around there. Alright? So, the names of these shapes, things like that, don't worry about them. Just know that if I give you a picture like this, and a compound that has this particular shape, and I would give it to you, you should be able to identify that it has a steric number of 7. Okay? Or when we get into some really common ones like this, then you'll be able to learn that those are steric 7s or steric 6s or whatever. Okay? So again, I suggest making the shapes with the models we have in class. They are helpful as far as the visualization aspect, and please ask any questions that you have.